Hello, friends. Good morning to all of you. Today we'll begin lecture number 13 on nth order derivative. So let's start nth order derivative. So in this first problem is what? Y is equal to sin x. Differentiating with respect to x. So dy by dx is what? Cos x. Again differentiating with respect to x. So d2y by dx square is what? Minus sin x. Again differentiating with respect to x. So d3y by dx cube is what? Minus cos x. Again, differentiating with respect to x. d4y by dx raised to 4 is plus sin x. Let us generalize it. This cos x can be written as sin pi by 2 plus x. Sin 90 plus x. 1 times 90 degrees. So sin changes to cos. 90 plus will go in second quadrant. In second quadrant, sin is what? Positive. Now minus sin x can be written as sin 2 into pi by 2 plus x. Now 2 times means even multiple. So sin will remain same as sin. And 2 pi by 2 plus x will go in third quadrant. In third quadrant, sin is one negative. This minus cos x can be written as sin 3 into pi by 2 plus x. This is again odd multiple of 90 degree. So sin changes to cos. And 3 into pi by 2 plus x will go in fourth quadrant. And in fourth quadrant, sin is what? Negative. So minus cos. And this can be written as sin 4 into pi by 2 plus x. 4 times means even multiple. Even multiple means sin will remain same as sin. And 4 into pi by 2 plus x will come in first quadrant. In first quadrant, sin is what? Positive. So proceeding in this manner, we get nth order derivative will be sine of n times pi by 2 plus x. In fourth derivative, 4 times pi by 2. Third derivative, 3 times pi by 2. Second derivative, 2 times. So in nth derivative, n times. Next is ax plus b to the power n. We'll go toward this at the end. 1 upon x. Differentiating with respect to x. dy by dx is what? Minus 1 x raised to minus 2. Again, differentiating with respect to x. d2y by dx square is what? Minus 1 into minus 2 x raised to minus 3. Again, differentiating with respect to x. d3y by dx cube is minus 1 into minus 2 into minus 3 x raised to minus 4. Again, differentiating with respect to x. d4y by dx raised to 4 is minus 1 into minus 2 into minus 3 into minus 4 x raised to minus 5. Now let us generalize it. This is minus 1 x raised to minus 2. This can be written as minus 1 squared into 1 into 2 is what? 2 factorial upon x raised to 3. This can be written as minus 1 raised to 3. 1 into 2 into 3 will become 3 factorial upon x raised to 4. Here it is what? Minus 1 raised to 4 into 4 factorial upon x raised to 5. Proceeding in this manner, we get nth order derivative of y will be in fourth order derivative minus 1 raised to 4. So in nth order into n factorial divided by x to the power n plus 1. Fourth derivative to power 5, third derivative to power 4, and 3 factorial and so on. Y is equal to cos x. Differentiating with respect to x. dy by dx is what? Minus sin x. Again differentiating with respect to x. d2y by dx square minus cos x Again differentiating with respect to x. d3y by dx cube sin x. Again differentiating with respect to x. So d4y by dx raised to 4 is equal to cos x. Now we'll generalize it. Minus sin x is what? Cos of pi by 2 plus x. It is 1 times cos, pi by 2. Cos changes to sin. And pi by 2 plus x will go in second quadrant where cos is what? Negative. And this can be written as cos 2 into pi by 2 plus x. So it is what? Even multiple the cos will remain same as cos. And 2 pi by 2 plus x will go in third quadrant. In third quadrant, cos is what? Negative. So minus cos. This can be written as cos of 3 into pi by 2 plus x. 3 means odd. Cos changes to sin. And 3 pi by 2 plus x will go in fourth quadrant. And in fourth quadrant, cos is what? Positive. And this can be written as cos 4 times pi by 2 plus x. 4 is what? Even, so cos will remain same as cos. 4 times pi by 2 plus x will go in first quadrant. In first quadrant, cos is what? Positive. So proceeding in this manner, we get nth order derivative of cos x is what? Cos of n into pi by 2 plus x. Log ax plus b. Differentiating with respect to x. dy by dx is equal to a upon ax plus b, which is same as a into ax plus b raised to minus 1. Again, differentiating with respect to x. d2y by dx square is what? See, derivative of inside function will be a. A is already there. So a into a will be what? A square minus 1 into ax plus b raised to minus 2. Again differentiating. With respect to x. So d3y by dx cube is what? Derivative of ax plus b is what? A. So into q. A square into a will give you what? A cube. Minus 1 into minus 2. Ax plus b raised to minus 3. Again differentiating with respect to x. d4y by dx raised to 4. Derivative of ax plus b is what? A. So a cube into a is what? A raised to 4. Minus 1 into minus 2 into minus 3 into ax plus b raised to minus 4. Let us generalize it. This can be written as a square into minus 1 upon ax plus b raised to 2. A cube into minus 2 times, so minus 1 square. And after that, 1 into 2 will give you a 2 factorial divided by ax plus b raised to 3. Now, a raised to 4 minus is what? 3 times, so minus 1 cube. Then after that, 1 into 2 into 3 will become 3 factorial upon ax plus b raised to b raised to 4. Proceeding in this manner, we get nth order derivative of y is equal to a raised to n. In fourth order derivative 4, third a cube, second a square. So in nth order a raised to n. Power 3, third derivative minus 1 square into 2 factorial. Fourth derivative minus 1 cube. So in nth derivative minus 1 raised to n minus 1 into n minus 1 factorial divided by ax plus b will have same power. That is ax plus b raised to nth order derivative, so power n. Next is cos 3 minus 2x. Cos 3 minus 2x. Differentiating with respect to x. dy by dx is what? Minus sine 3 minus 2x into minus 2. Again differentiating with respect to x. So d2y by dx square, derivative of minus sign is what? Minus cos 3 minus 2x, again into minus 2. Already minus 2 is there. Minus 2 square. Again differentiating with respect to x. So d3y by dx cube, derivative of minus cos is what? Plus sine. Into derivative of 3 minus 2x is minus 2. Already minus 2 square is there. So minus 2 cube. Again differentiating with respect to x. d4y by dx raised to 4. Derivative of sine is what? Cos 3 minus 2x. Minus 2 cube is there, which is constant. Into derivative of 3 minus 2x is again minus 2. So that will give you what? Minus 2 raised to 4. Let us generalize it. This minus 2 is there. Minus sign can be written as cos of pi by 2 plus 3 minus 2x is the angle. Keep as it is. Cos changes to sine because it is odd multiple and angle is in second quadrant where cos is what? Negative. This can be generalized as what? Minus 2 square. Minus cos can be written as cos of 2 into pi by 2 plus 3 minus 2x. It is 2 times pi by 2. The cos will remain same as cos. And 2 pi by 2 plus will go in third quadrant. In third quadrant, cos is what? Negative. And this can be written as minus 2 cube cos 3 times pi by 2 plus 3 minus 2x. So 3 means odd. Cos changes to sine. 3 into pi by 2 plus something will go in fourth quadrant. And in fourth quadrant, cos is what? Positive. This is what? Minus 2 raised to 4 cos of 4 into pi by 2 plus 3 minus 2x. 4 times means even multiple. Even multiple means cos will remain same as cos. Angle is going in first quadrant where cos is what? Positive. So proceeding in this manner, we get so nth order derivative of y will become what? Minus 2 raised to n into cos of n times pi by 2 plus 3 minus 2x. Y is equal to e raised to x cos bx plus c. Differentiating with respect to x, dy by dx is equal to u into v, e raised to ax derivative of cos bx plus c is what? Minus b sine bx plus c plus cos bx plus c into derivative of e raised to x is what? A e raised to ax. We can take e raised to ax common. So in bracket we'll get a cos bx plus c minus b sine I want to make this bracket as expansion of cosine. For that, multiplying and dividing by a root of a square plus b square. So dy by dx will be what? Root a square plus b square e raised to x a upon root a square plus b square cos bx plus c minus b upon root a square plus b square sine bx plus c. Write this as equation number 1. Draw a right angle triangle. Take this angle as what? Alpha. Hypotenuse will be what? Root a square plus b square. And now I want this as expansion of cosine. So A must be adjacent side. B must be opposite. Therefore, sin alpha is what? B upon root. Cos alpha is what? A upon root. Tan alpha is what? B by A. So this implies alpha is what? Tan inverse B by A. Therefore, equation 1 becomes dy by dx is what? Root a square plus b square e raised to x cos bx plus c into cos alpha minus sin bx plus c into sin alpha, which is equal to root a square plus b square e raised to x cos bx plus c plus alpha. Again differentiating with respect to x. So d2y by dx square root a square plus b square is constant, take outside. We will get e raised to x minus b sin bx plus c plus alpha plus cos bx plus c plus alpha into derivative of e raised to x is what? A e raised to x. Now we can take e raised to x common. Root a square plus b square e raised to x common will give you what? A cos bx plus c plus alpha minus b sine bx plus c plus alpha. Again, we want this bracket as what? Expansion of cosine. For that, multiply divided by root a square plus b square. So d2y by dx square will become root a square plus b square square into e raised to ax bracket a upon root a square plus b square cos bx plus c plus alpha minus b upon root a square plus b square sine bx plus c plus alpha. So this is cos alpha square e raised to x cos alpha into cos bx plus c plus alpha minus sin alpha into sin bx plus c plus alpha. And this entire thing will become what? Root a square plus b square square e raised to x this will become cos bx plus c plus alpha is what? 2 alpha. Proceeding in this manner we get so nth order derivative root of a square plus b square raised to n e raised to ax cos bx plus c plus n alpha, where alpha is what? Tan inverse b by a. This is the answer. Ax plus b to the power m. Let us try this. So here different cases are there. Case 1. Y is what? Ax plus b raised to n. Case 1. When m is greater than n. That means we'll cover nth order derivative first. Then it will continuity length is what more. Differentiating with respect to x. Dy by dx is what? M into ax plus b to the power m minus 1 into a. Again differentiating with respect to x. d2y by dx square m into m minus 1 ax plus b raised to m minus 2 into a square. Again differentiating with respect to x. d3y by dx cube is what? M into m minus 1 into m minus 2 ax plus b raised to m minus 3 a cube. Again differentiating with respect to x. So d4y by m minus 1 m minus 2 m minus 3 ax plus b raised to m minus 4 into a raised to 4. Proceeding in this manner, we get nth order derivative d raised to n y by dx raised to n. M is what? Larger. So here it will be what? M into m minus 1 into m minus 2 and so on. It is up to fourth derivative up to 3. So nth derivative will be what? Up to n minus 1. N minus 1 will be what? Plus 1. A raised to n and ax plus b raised to m minus 4, तो m minus n. This will be nth order derivative when n is greater than n. Case 2, when n is same as n. So nth order derivative will be m into m minus 1 into n minus n is same as n. So n minus n will become 0, so 1. Into a raised to m or n, 1 and same thing. Ax plus b raised to m minus n, because m and n are equal. This is what m factorial, or you can say n factorial. A raised to n into ax plus b raised to 0. But m and n are equal to n factorial into a raised to n. And case 3, when n is less than n. In that case, we will cover up to n. N will be give you what? Constant. And further derivative will be what? 0. So dny by dx raised to n will be 0. So this is the answer. Thank you very much. Today's quote is what? Get busy in living. जीने में व्यस्त रहो और get busy in dying. या तो आप मरने में व्यस्त रहोगे. तो बेटर है, लाइफ एक ही बार मिलती है, तो जीने में व्यस्तता दिखाइए, ना कि मरने में. थैंक यू वेरी मच.